You see shapes like triangles and squares everywhere, right? But have you ever stopped to think about the rules they have to follow? Turns out there's this hidden code, this beautiful logic that controls every single one of them. And today, we're going to crack it.
Okay, so right off the bat, let me ask you something. Take a look at these two things. To you and me, they might both just look like lines on a page, but in the world of math, one is a very specific type of shape, and the other is, well, it's just a scribble. So what's the deal? What's the actual difference?
And here we go. The one on the left, that's what a mathematician would call a curve. The one on the right is our star player, a polygon. Getting from the first to the second is actually pretty simple. It's all about adding a few key rules.
So let's start with the absolute basics. Before we can get to the really cool secrets, we got to make sure we're all speaking the same language.
All right, get ready for the first little surprise. When you hear the word curve, you probably think of something that, well, curves, right? That bends. But in geometry, a curve is literally anything you can draw without lifting your pen. And yeah, that means even a perfectly straight line is technically a curve. Kind of weird, but that's the rule.
Okay, so now that we know what a curve is, we can split them into two main types. You've got open curves, which have very clear start and finish points, and then you've got closed curves. These are the ones that loop all the way around and connect back to themselves, so there's no real end at all.
Okay, so we have our building blocks. We know about open and closed curves. Now we can finally define the star of the show. Let's get super specific and lay out the 3 non-negotiable rules that a shape has to follow to officially be called a polygon.
And here they are, the 3 big rules. Rule number 1, it has to be closed, no gaps allowed. Rule number 2, it has to be made only of straight line segments, no bendy bits. And rule number 3, it's got to be simple. And simple is a technical term here. It just means the sides can't cross over each other.
And this is super important. You have to follow all 3 rules. Break just one, and you're not a polygon. So look at these examples. The first one, nope, it crosses over itself, so it's not simple. The next one, it's got a big gap, so it's not closed. And the last one, well, that's got a curved part. So none of these guys get to join the Polygon Club.
So, once you're in the Polygon Club, there are still 2 main families. First, you've got your convex polygons. Think of these as the standard ones, where all the corners are pointing outwards. But then you have concave polygons. These are the ones with at least one corner that points inward, like it's been pushed in. It creates a little cave in the shape, which is an easy way to remember it.
Okay, definitions are done. We know exactly what a polygon is. Now we get to the really good stuff. Because it turns out that the simplest polygon, the humble triangle, holds a secret. A secret that unlocks a powerful formula for every single other polygon in existence.
Just think about it for a second. We all learned in school that a triangle has 180 degrees inside, right? But what about a shape with 5 sides, or 6, or 20? How could you possibly figure that out? It sounds like it should get super complicated, but there's a pattern, and it's shockingly simple.
And here it is. This is the big secret. You can take basically any polygon, pick one corner, just one, and draw a straight line from it to every other corner. And what happens? Bam! You've just chopped the whole thing up into a bunch of triangles. That's the key right there.
And this is where the pattern emerges. It turns out that for any polygon with n sides, you can always split it into exactly n-2 triangles. So a pentagon, which has 5 sides, you get 5 minus 2. That's 3 triangles. A hexagon with 6 sides, you get 6 minus 2, 4 triangles. It works every single time.
So let's put it all together. If you have n-2 triangles, and each one has 180 degrees, you just multiply them. The number of sides minus 2 times 180. And there you have it, a single, elegant formula that tells you the total degrees inside any polygon. That is seriously powerful stuff. All right, so we've cracked the code for what's going on inside a polygon. But what about the outside? You guessed it, there's another incredibly simple rule for the exterior angles, and this one might be even more surprising.
The best way to think about this is to imagine you're a tiny person walking along the perimeter of a shape. You're walking in a straight line, you get to a corner, and then you have to turn to walk along the next edge. That angle you turn, that's the exterior angle.
So you keep doing this. You walk, you turn. You walk along the next side, you turn again, all the way around the shape. By the time you've walked the whole perimeter and you're back where you started, facing the exact same direction. All those little turns you made have to add up to one full circle.
And what's one full circle? It's 360 degrees. And this is the mind-blowing part. It doesn't matter if it's a triangle, a square, or a polygon with 1,000 sides. If you add up all those little turns, all those exterior angles, the answer is always 360 degrees. Period. How cool is that?
Okay, so now let's focus on the VIPs of the polygon world, the regular polygons. These are the perfectly symmetrical ones, where every single side is the exact same length and every single angle is the exact same size. Think equilateral triangles and perfect squares.
This is where our formulas get even more useful. Because all the angles are identical, we can figure out the size of just one of them. We still find the total sum, that's n minus 2 times 180, but then we just divide that total by the number of angles, n, and boom, you know the size of each interior angle. And for the outside, even easier. It's just 360 divided by n for each exterior angle. All right, time for a final challenge to see how powerful these rules really are. Is it possible to have a regular polygon, remember, perfect sides and angles, where every single interior angle is exactly 105 degrees? Let's see what the math says.
And the rules give us a definite, flat-out no. It's impossible. If you plug 105 degrees into our formula and solve for n, the number of sides, you get a crazy answer, 4 4/5. You can't have 4/5 of a side. So the rules themselves tell us that such a shape just can't exist. It breaks the laws of geometry.
And that's it. We went from a simple scribble all the way to universal laws. And these aren't just descriptions. These rules actually define what's possible and what's impossible in the world of shapes. It just goes to show you there's a hidden mathematical code underlying everything. So the next time you see a stop sign or a tile floor, what are you